This is a very special edition of the Developers Log, and we have here with us
Samuel Donkor.
Please come and join me. Yeah.
Okay. Hello, everyone. Welcome to another entry of the Developers Log podcast. Today, I'm here with Samuel Donkor. I didn't know Amankwa was part of your name, but Samuel Donkor.
Oh, yeah.
Hello, Samuel. How are you doing?
Hi, Joseph. I'm doing pretty well. Thank you so much. How are you also doing?
Yeah, I'm also good. It's very good to have you on board.
Yep. Yeah. I'm actually glad to be here. Yeah.
All right. So, as you know, or as things usually go, can you give us a little introduction of yourself?
Yeah, for sure. So my name is Samuel. I think I should actually add the Donkor so that we clarify that, yeah, it's part of my name. So Samuel Donkor.
Sure.
A middle name in the box somewhere. So I'm just like bringing it out. Yeah, so my name is Samuel Donkor. I'm currently a software engineer at a startup called Life Spaces, and also an AI research fellow at In Vivo Group. So I think what actually led me here basically goes back to like some years ago. Basically when I was like very young, around like 9, 10, I think that was when I actually saw my first computer, right? So yeah, my dad bought us like our first computer, and then he had like connected to it to the internet. So it was at that time was like the LAN cable together with like a modem, right? Yeah, and actually that was like really interesting, and I got curious. So I started asking like a bunch of questions, right? So what if I actually remove this? Would it work, right? Yeah, so I think I started asking too many questions. I actually felt bad for him myself, right? And I just like toned it down a bit. But then I think that was like really interesting. Was really interesting to see like, and also to understand how the internet actually works. That actually also piqued my interest into the tech space, computers, and programming. But I think the real turning point was in high school. So in high school, I was actually a science student, so did everything from biology, chemistry, physics, math, and all those stuffs. But then I did realize that most of the stuff I was actually learning, I had to actually memorize them, and I'm no big fan of those kind of that kind of way of learning, right? So yeah, I used to spend like a lot of time at the library. So I'd go to the library just to get like a high level overview or like a more in-depth knowledge, understanding of what was being taught. And I also got the opportunity to read some other books. So, for example, computer science books, programming books, and actually I came across Python. And yeah, so I got back home and then I researched more into it. And I think my first Python programming book was Automating the Boring Stuff with Python. So I literally printed an entire book. Yeah, and then printed an entire book and then put it in my chalkboard together where my food is stored. Then went to high school, right? So when I had like some free time, I'd pick it up, go to the classroom somewhere, and then just read it, right? And then just actually write or implement the algorithm on a sheet of paper. And then when I went back home, yeah, when I went back home, I would actually try to debug it on my computer, right? So at that time, boarding house, you actually didn't have access to the computer every time, right? Unless maybe it's like ICT, right? That's when you actually had access to computer. So I'd come back home, debug, and then run it, and then actually try to see if it actually works, right? So it was actually really cool. So my very first Python my very first Python program was basically a Python script where it actually to enter your name, your age, some basic information, and then it generates fire for you, right? At that time, it was magic.
Yeah.
It felt like really, really cool, right? So I'd give it to my sister or my brother, right? Hey, could you like enter your name? Could you enter your date of birth? Could you enter your age, right? And then it generates a bio for you. It's like really cool. That time it seemed like magic, right? Yeah. And also, I think one of the stuff that was like really interesting was that at that time, that was when BQ6 had actually come out. So Baymax, there was like this animation movie. So hey, I'm Baymax. That's not how that stuff, right? Yeah. So yeah, I like that animation so much that it also like piqued my interest into like the health and then the biospace, right? So in biology class, there was this topic that the teacher was treating. I think it was preventable diseases, right? So you had like all diseases, you have like their symptoms, you have like their causes, then how to prevent them,
Yeah.
right? And then there were like 10 diseases that we're actually looking at. And I saw like this part and I was like, oh, okay, every disease has a symptom, a cause, and a way to prevent it. What if I actually created like a Python script where you enter your symptoms, then it gives you how to prevent it, right? So at that time, it was like a bunch of if-else statements stuck, right? Yeah. So you enter the sentence, it gives you like, hey, how should I actually prevent this, right? And then to like spit an like a list of steps to follow to actually prevent it or to actually avoid it in the first place.
Yeah.
And it felt really cool. So I think at that time it actually triggered something in my mind. I was like, whoa, this is cool. If this is something I actually want to do for a career, right? And then I went on to uni, told my parents, actually I want to do computer science, right? It was like, okay. Then I came to Key University to do computer science, and it's been pretty fun. For example, meeting guys like you who are like building stars, right? Yeah, it was. I think one our class like one of the best classes, I guess. Yeah, so it's been really fun, and yeah, that's a bit of my journey into tech, a bit of my journey so far. Yeah,
Wow.
yeah,
That that was crazy.
yeah. I know.
Wow. Okay.
Yeah.
Uh, so how do I proceed from here? Okay. Just to clarify, because I didn't really catch that part. You mentioned you were working at a startup called Life.
Life spaces.
Oh, Life Spaces.
Yeah.
Okay. Okay.
So the current project that we are working on is Life Spaces, but then the parent company is called Smaletics. So Life Spaces basically the goal or the aim of the project is actually democratize out of home advertising, right? To basically give people access to so for example, it could be like retailers or it could be people actually want to advertise their stuff. So for example, you own a space, right? And then you can actually monetize your screen using data so that people can actually like show their ads on your screens, and then yeah, basically this kind of stuff. So you actually want to monetize out of home advertising so that it's actually accessible to everyone, right? Yeah, so that's what Lysis actually does. So using data technology to actually democratize the out of home advertising space. Yeah.
Okay. Okay.
Yep. Yep.
Wow. Okay. Okay. So, moving on from there.
Yeah.
What was the very first thing you ever tried doing with a computer? When I think you said you started experimenting with a computer when you were around 9 years old, right? When your dad had the computer in the house and the LAN cables and everything. What was the very first thing you tried doing with a computer?
Yeah, so this is a funny story. I think my very first interaction with a computer, or like, yeah, face to face with the computer, has actually been first taking it apart. So I think from then, my dad had like a few laptops, right? And then I'll try to take it apart and try to put it back together, right? Most of the time, it actually didn't work, right? Yeah. So I think for every major electronic device that actually got spoiled in our house,
You were the cause.
I was the cause. I was the cause, right? So that was like my very first interaction, or like my very first intro to computers. Right, like destroy most of them. But then I actually wanted, I think out of curiosity, wanted to know like what exactly was going on, like under the hood, right?
Yeah.
And I think from there, actually went on to like learning Python. I built like that bio generator,
Yeah.
that very cool bio generator app, right? Yeah. Yeah,
Okay. And the bio generator, it was a terminal application, right? So you
exactly.
interacted. Okay. Okay.
Exactly.
Wow. Printed a whole book.
Yeah, was like stacks of paper. I mean, I wasn't paying for it, right? The
Yeah.
paper was there, and then there were like papers inside. I was that's told myself, and I went to print like a whole book out, right? Then I just put it in my bag, just send it away, just like that. I mean, I wasn't paying for it, so
Oh, okay. Okay.
yeah.
All right. So, do you still mainly use Python for the things you do, considering the fact that the book was about Python, right? Covering the Python programming language.
Right. So I think one of the most important things I think working at Lightspace, for example, is because it's a startup, I'm actually able to have the opportunity to work like cross functionally. So I could work like on the backend team, the front end team. So mostly on the backend team, it's purely Python. But then on the front end, I actually mainly use React and then JavaScript. But then I also like do some Python. Yeah. So it's like Python and JavaScript and yeah, some other stuff in between.
Yeah.
Yeah.
Okay. All right. All right. All right. Okay. So currently, what's your primary focus at the moment?
Yeah, for sure. So I think because I'm currently experimenting with lots of stuffs, I think like I did say, my journey has been like um, driven or like led by a lot of experimentation and figuring stuff out. So currently, aside like working on the startup, which I've had like a really great learning experience from, one of the things I'm actually also looking at is research. So researching into the biospace, the healthcare space. And I think that's something I've been interested in for a while since high school, like I did mention, where I took like that biology lesson and then built that chatbot from.
Yeah.
So I think, yeah, that's been like my direction. So it's been like something I do, while I still fascinated by the startup scene. Something I also like to build in that space too. Yeah,
Okay.
yeah.
And why biology?
Yeah. I think I remember my first one of the first books I actually really got fascinated by was I think I was really young. There was like this illustrated biology book. You could actually feel the page as if it was like 3D, right? So it had like the human anatomy inside it, right? You could have like the heart.
Yeah.
But then when you fill the page, you feel like it's sort of like the 3D, right? It was like really interesting. I was like, oh, okay, this is cool. I actually tried to keep that book for a very long time, but unfortunately, someone stole it. So that was like the last time I saw it. Yeah. So I think that's when my interest in biology started, and then going to high school to learn science, where I should also get interested into like the biology, the physics, and those stuff. So basically, like sciencey stuffs.
Yeah.
I think it was like really interesting to know like some other stuff that's actually happening and how like the world actually works, right? The fundamentals. Yeah, the cellular level, the forces, for example, in the physics, the forces that actually like work on stuffs, right? Yeah. So yeah, yeah.
All right. All right. All right. So you recently completed university, and I think you've done your national service, right? Okay, the usual. What
Yeah.
are your plans moving forward? I know you're currently working at a startup. What are your plans moving forward? Especially considering the fact that you mentioned research and you are really heavy on research. Have you considered pursuing a master's program? Because that's usually where you have more exposure to research.
Right, right. Yeah, I think that's a great question. I think for me specifically, I actually like to build stuff. I mean, I like research, but I also want to build stuff. I think mostly the opportunities I've been actually looking at are basically at the intersection of both, right? So I did mention that at In Vivo Group, I'm actually an AI research fellow. So there, I actually get to build stuff and also do research, right? So one of the research that we actually did was, I think it actually came out even as a paper, computing the life sciences from algorithms, computing the life sciences. We actually looked at algorithms in the life sciences from expert systems to currently large language models and biological design tools, right? And one of the things I actually read, I think the supervisor I'm actually doing the research with, he actually wrote a piece that I actually read, which was like quite interesting. I've had like a lot of people also like talk about it, where in the life science space or like the biotech space, right? There's like this barrier as to you only need people currently. That's the situation. They're only looking for people who have like PhDs, right? And if you have like a master's, you have like bachelor's, you have like experience, that actually limits you. So there's like this barrier to that, right?
Yeah.
But you actually explain as to why um, it actually doesn't need to be that way, right? So basically, PhD, basically the title of the blog is PhD not required, right? So it doesn't need to be that way where there strictly needs to be a PhD required for you to enter into the biospace. And then he was talking about how it actually limits the opportunities and then the innovations that could actually potentially happen. Because, for example, you could have someone coming out from bachelor's or master's who have like they actually have the drive, right, to do some stuff, right?
Yeah.
Yeah. So I think that's something that actually struck a chord with me, and I think that's something I also live by. That you actually don't have to be like an expert in something to actually like make a breakthrough in that or actually build something in that, right? So I think moving forward, still building stuffs, working with live spaces, trying to see it through, and then like help people actually use data to take ownership of how the their data actually gets to their customers, or like their product actually gets to their customers. And also in the research space, I'm also looking at building and then researching at the same time. Um, Possibly, I could actually go for grad school, but then I think that's something I'm actually still considering.
Yeah.
Yeah, yeah.
Okay. All right. So first thing, AI research. It's your. Do you? I think one of your main interests is within the AI field, right? Like, yeah, AI systems.
Yep.
Okay. So what exactly? No, actually, before that, what exactly is AI?
Yeah, I think that's a great question. I think when people hear about AI, they mostly think ChatGPT or LLMs, which is
Actually, I think of Jarvis.
yeah, exactly right. So that's yeah. So when people think about AI, yeah, Java is an AI, and they're actually not wrong, right? But then I think people's knowledge as to what AI is sometimes limited. For example, people actually don't have like the technical skills, for example, or not in, like the computer science field, for example, right? So I think when you think about AI, you could think about AI as like a whole field. AI could be like physics, right? It's like a really broad field, right? And I think a really great analogy would be that AI actually has an intersection with statistics, right? So most of the stuff that we use in AI actually it takes something from statistics to actually implement those kind of stuff, right? So you can think of AI as this huge umbrella of field, right? And then under that, you have soft field. So AI is an umbrella. Under that, you have expert systems. Expert systems are considered AI. So let me take you back to, let's say, the 1990s or like way back, a century ago, if you will, right? Where people actually or experts, right, had this knowledge base, right, and then they could actually query it to get information from it, right. So they actually fit into all their expertise into, say, a computing system or a program, and then essentially you could actually query from it and then get like instructions or guidelines or advice. So depending on the context. So for example, in healthcare, I think there's something called Dendral in the healthcare space, basically an expert system in that space, right? But
Okay.
then one thing with expert systems is they're actually limited. So for example, if you move them out of their context, that knowledge base you have becomes not really helpful, right? So moving from then, you can actually also compare that to traditional programming, right? So with traditional programming, you have, say, your function, right? And then you have your data, right? And then you feed your data into the function and then expect an output for you,
Yeah.
right? That means that for every scenario, or for every scenario that the data changes, you have to adapt the function to that to
So that
get
it
a
can be,
different
it can handle the data.
exactly right. But then there's also a problem with that, like we did mention. So what if you actually have your data, right? Sorry, and then your data actually learns from your program actually learns from the data and then gives you like the rules, right? So if you think of it as a linear path, so you have the rules here, you have your data here, right? And then you have your function here, right? And then the function actually learns the intricacies of the data to give you like the rules, which would basically apply to like every context you place in based on what the data was trained on, right? So you can think of machine learning as a subset of the AI that we talked about, right? So machine learning basically is determining or basically recognizing patterns in data, right? So it could be you are given like a bunch of apples, right? And then basically using that data to differentiate which apple has like a green color, a red color, or a yellow color, right? So basically determining patterns. And I think one other application of machine learning could be not only images, but then it could be like text data. It could also be time series data, right? So you could use machine learning to determine basically a functionality or abnormality in a system if it's like a time series data. It could also be like climate data, where you have like a time series of, say, the temperature over time. Then you can actually determine like anomalies, right? And then under machine learning, right? So under machine learning, you have like several techniques, right? So you could have supervised learning, unsupervised learning. But then there are also techniques or like very specific paradigms like artificial neural networks, right? And then artificial neural networks, they actually work really well with high dimensional data. So with machine learning, which we talked about, they actually deals with like low dimensional data like text, for example, or like time series, for example, which basically use a logistic regression to solve them. Artificial neural networks actually work on very high dimensional data. So everything from videos to images, right, to sound, right. And that's where we actually get deep learning, right? So deep learning basically has a bunch of artificial neural networks, which actually learns from the data you feed in, right? To basically give you, like we did mention, the rules or like the program, which moving on will also be used to infer, right, on other new data you give it, right? And so that's when we actually have deep learning based on the artificial neural networks for machine learning, right? And then inside that deep learning, that's when you actually get the large language models, right? So LLMs like ChatGPT, Gemini, Claude, or what have you, right? So these large language models, like we said, they are actually basically deep learning, but then they learn from a bunch of internet data, right? So they learn from that data and then they're able to generate human text or human output, for example. So I think overall that is classified as generative AI. So basically, that generative AI that we're actually hearing about, that actually came about by the paper called "Attention is What You Need." Is all you need from 2017, which basically is based off the transformer architecture, right? So that's how we got like generative AI, where it learns from data, but then instead of say predicting or giving you like spitting an output, you actually get like fresh new content based off of the data that's actually generated, right? So yeah, I think if you think about it in that way, right, you actually basically are able to classify as to what is AI and what is not AI, or the very different types of like subsets that we have like within the AI field. And then I think it um, also really helps to clarify that so that people actually don't confuse that with something that is not AI, for example. I think that's like a really great analogy. Maybe you could actually go more in depth into that. Yeah.
Okay.
Yep.
Okay. I I have to be honest. There are some portions that I am a bit lost, but I think I get the gist of it. So AI with the umbrella term AI, right? We have different subsystems like the machine learning, expert systems, all the various variations. And okay, so there was something I wanted to ask while you were talking. With the expert systems, you give the example of I think Dendra, and you were saying that it's sort of like a knowledge base, and back in the olden days, people used to, if they have maybe like a query, they would check the knowledge base and see if it can give them an answer, right? So with that, you gave the analogy of using like a function in programming where it takes data input and then it gives an output. But then if you give it inputs that it's not expecting, because the function has its own set of rules. So if you give it inputs that it's not expecting, it doesn't know what to do with, it won't be able to generate an output for you, right? So with
Right.
machine learning, what it does is it's actually, instead of creating the rules first and then getting the data, giving it to the function and the function giving you the output, it actually studies the data and then creates the rules. That's it.
Right. Right. Exactly. Right.
Oh
Yeah.
my goodness.
Yeah. Yeah. I think you did a great job simplifying that. That's exactly what it is. Yeah.
Okay,
Yeah.
okay. Ah, my mind was bedded. Okay, let me see. Yeah, so you mentioned a few other things like supervised learning, high dimensional data. And I think the high dimensional data, there are things like videos, images, and sound, right? So it means that
Yep.
with machine learning, you are actually able to analyze things like videos, things like images, things like sound. Yeah, and actually that reminds me, I
Right.
once heard there was some initiative to try to determine the communication, the means of communication between, I think it was dolphins, and they were actually analyzing the sounds. Did you hear anything about that? You heard about it?
Um. Yep.
Oh,
Yeah.
I mean, you are the AI guy, so you should, I shouldn't be
Um.
surprised.
Yeah. I heard of it in past. I think it was a documentary. Yeah.
Oh, okay. Yeah, yeah. Okay.
Yeah.
So high dimensional data. So does text also form high dimensional data? Is it part of high dimensional data?
Right. I think that's a great question. So I think when it comes to machine learning and deep learning, I think, for example, one way we could think about it is these inputs that we are talking about, for example, text, image, videos, the computer actually doesn't understand these, or they actually don't know what they are, right? So we have to actually convert them into computer language, right? So we have to convert them to zeros and ones,
Yeah,
basically,
binary.
right?
Yeah.
So you take the text, exactly, finally, yep, and then you convert it to the computer language, and then you learn the relationship between it, right? Um, so I do think you could actually classify text as higher dimensional data, depending on the context. I'm actually really not sure. Maybe you could actually like look more into
Oh,
that.
okay.
But I think we actually classify it as higher dimensional data because essentially you actually, for example, when you think about like large language models, because the computer actually doesn't understand the text that you've actually given it to it, I think one first step you actually need to do is convert it to embedding. So what embedding does is it's like a plane, a three-dimensional plane, right? Which actually maps each word to a different part in the plane, right? So how that becomes helpful? One way that becomes helpful is that, for example, if you input into the program, say a cat, right, and then you input into it a dog, and then you input into it, say, a human, right? One thing you realize is that the cat will be more closer to the dog than both of them to the human, right? And so at the very first stage, you actually find similarities between two stars, even before like the other like element part,
Yeah.
right? So yeah, I think that's like also like a really useful thing to mention when it comes to like text, where you have like the embedding space. We're actually able to like find similarities. Actually, we actually did a project on that. We actually mapping research projects, which are in, or research papers, which are actually in close proximity to each other. In that case, for example, if we feed into it a particular research paper, it will generate other ones which are similar to it based on the abstract or the topic or say the keywords inside it, right? Yeah, yeah,
All right. All
yeah,
right.
yeah.
Okay.
And I think a beginner's understanding or a beginner's explainer to AI could be to think about how a child learns, right? So, for example, you got your younger brother or younger sister, say a console, and I should be specific here because I did see a meme where I did see a meme where the kid actually asked the dad to buy him a console, then he got him a console for Wi-Fi and then internet, right? So,
Oh, okay, 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 okay.
so let me be specific here.
Game
Let's see
console.
Wi-Fi. Exactly, right.
Okay.
So let's say you give them one, right? They actually have no prior intro to gaming, right? And then you give them the pad, right? Then the very first game that comes on, say Mario, and then they actually start to experiment with it. Say they can actually move up, right? They can actually move left, can actually move right. But then when they moved right, they actually hit something, and then the game restarted. So now in their mind or in their brain, they've actually noted that down. Say if I move too close to something like this, I'd actually have to restart, right? And then during the course of the game, they also move forward and then they find something, say, like a coin. And then they actually go closer to the coin and then get it. It actually increases, say, their life, right? Or let's say the rewards that they get,
Yeah.
right? Say, oh, okay, cool. Maybe let me get like more coins. Or maybe I become bigger when I get more coins. So let me become more bigger, right? So now they've basically learned stuff within the game just like from the start. So I think that's like a really good analogy as to how machines also like learn in some way. Yeah, you actually give them the data and then just as like babies learn, they also like do some experimentations and trial and errors just to basically analyze and then detect like the patterns within the data, for example. Yeah. Yeah.
Okay. All right. Yeah. Okay. So coming back a little bit, um, you mentioned, yeah, okay, so you mentioned deep learning, you mentioned neural networks, deep learning, and then large language models. So I think you mentioned something along the lines of with machine, you take machine learning principles and then I think you aggregate that and then that takes you toward deep learning.
Yep.
Okay.
Yep.
Wow. I am impressing myself.
Yeah.
Oh, okay.
Yeah.
Then from deep learning, that's where you actually head toward being able to build large language models, right?
Yep.
Okay, okay, okay. And with the large language models, so with the example you gave about the text data, right? How you have a 3D space and then you have the words mapped out within the 3D space. You have certain words that are closer to each other, certain words that are further apart. Is that basically how a large language model works? So if it wants to, I think with the example of things like ChatGPT, Gemini, uh, or the others, if it wants to generate text, it actually finds the words that are closely related to each other within that 3D space and then generates it. That's how it works.
Right. Right. Right.
Okay, so
So,
so if I were to train hypothetically or make my own large language model and I used words specifically relate s- and I used how do I and I use negative words, right? Like not negative in the sense of like insults, but a negative as in demoralizing and those sorts of things. It means that if I am to generate some text with that large language model, it's going to be very pessimistic towards me.
right. Right.
Okay.
Right.
All
Right.
right.
And actually, we also expand on that, on the large language models part. So, in training large language models, the way to think about them is like in stages, right? So, you could take like ChatGPT. Let's say you want to build your own LLM or large language model, right? The very first step would be your data, of course, right? But then it needs to be like a bunch of data, right? So, it could be like Wikipedia pages, like all Wikipedia pages, most books on the internet, right? Articles, Reddit posts, but then you also have to be conscious about like the type of data they actually collect, right? Yeah. So you could have like a bunch of data on this end, right? Then the very first stage is actually pre-training the model. So pre-training the model is basically training the data, training the model on those specific models, right? But then at that stage, it's actually not conversational yet. The only thing it can do is at best predict a word for you or give you like a word output, right? Based on, let's say, an input you've given it, like, for example, or on its own, actually like generate a word for you, right? And then moving on, that's when you actually fine tune the model. So fine tuning it is when you could have like um, trained on it on downstream tasks. So for example, if you want to have your large language model to be like more conversational, you could have say a pair of question and answers, right? And let's say you could have a question like, what is a car, right? And then basically the answer is what you think the large language model should answer us, right? And then it learns from this, and then basically you could have like a conversational one. And then to be even more accurate and then to be like even more conversational, you could have like reinforcement learning with human feedback. Because if you have like just one answer as to what a specific question should be like, it actually like gets pretty predictable very easily, right? So with reinforcement learning with human feedback, not only do you have like several answers, right, for one particular question, you've also graded them. Let's say for this particular question, I'll give like this particular answer say zero point 0.5. Now I give the answer the other say 3, 2, 1, right? So the model actually learns based on that, then gives a higher preference to the answers based on what you've actually graded them as or rank them as, right?
Yeah.
And then from there, you can actually have like very more dynamic outputs So I think there was like this feature of sort GPT where during the conversation you could actually generate two outputs for you, right? And then you have to select one. Actually feeding that back to the model for it to actually learn from it, right? So yeah, that's how it actually works. I think on the large language model perspective, as to how you have like your data, you pre-train it, and then you fine tune it, then you have like a more conversational one. But then the interesting thing is that on the pre-training part, right, it takes lots of compute power and lots of data that if you're an individual, you can actually do it on your own, right? So they're actually open source models, pre-trained models, which you can take, for example, and then fine-tune them for your own downstream tasks. And they actually perform really well, sometimes even better than the proprietary ones that we actually use, right? So I think now is the best time more than ever to actually be an AI developer or like a developer, right, in the world, right? Because you have like all the tools out there, for example, on Hugging Face, the GitHub of machine learning, right, with lots and lots of models out there, right, lots and lots of data, right, and then you can actually take those models, fine tune them for your own specific tasks, and actually what that actually helps with is actually democratize who can the people actually build machine learning models because now it's not limited to big tech, right? Now, like individual people could actually like build their own stuffs, very useful stuffs. Yeah.
Okay. With the okay, so supposing I wanted to fine tune my model for a certain purpose, how do I actually identify the base model I should use to for that fine tuning?
Right, that's a great question. So there is a leaderboard, I think it's called Chat Arena, which actually ranks all the large language models out there. So basically, you could have like the open source ones, the proprietary ones, but then you could also fill out like the open source ones, right? And then if you see on what task they actually perform well on, right? So let's say you want to do it could be like a classification task, for example. You could see the very specific large language model, open source one, which like really ranks like to the very top of it, and then you could choose it. You also have like much more other stuff you're actually looking at. For example, some metrics that are actually like um, very keen to you, which you're actually looking for. And then based off of that, you can actually rank them um, or filter them out and then choose the one that actually best suits you. So I think it's also like a really useful tool as to get like the comparison between the models out there and the metrics that was actually used to evaluate them and which one is like best for which specific task, for example. Yeah.
Okay. And with the so is it the creation of the large language model or is it the fine tuning that is very resource intensive or both of them are resource intensive?
Yeah, that's a great question. So I think the one that is actually much more resource intensive is a pre-training stage where you just gather like all your data, right? You want to build like the foundation model from scratch, right? So you gather like all your data. You are basically starting from scratch.
Yeah.
So you gather like all your data just to train the model that basically like predicts a rate, right? So but when it comes to like the fine tuning part, the only thing is you need like the data, and then there are actually ways to actually fine tune it in such a way that you don't actually require um, like a lot of resource. So, for example, you can actually fine tune with reinforcement learning with human feedback. There are actually various techniques you can actually use. For example, you can actually use LoRa, right? It's like a technique to actually help prevent or help reduce the resource intensivity of the training part of the model, right? So it's much more easier to fine tune than to actually build your own pre-trained
Pre-train,
model.
yeah.
Yeah.
Okay. Okay. All right.
Yep.
So I just want to clarify. Laura, is it double LORA?
LoRa is LoRa. So
Oh,
low rank.
oh.
Yep. Low rank adaptation. I think it's a concatenation of the word.
Oh,
So low rank.
yeah. I think I've actually seen. Oh, yeah. Okay.
Yep.
Yeah, yeah, yeah.
Yep.
All right, all right, all right, all right. Okay, so identify the large language model you want to use, then fine tune that, and then you can have your own personal large language model that actually performs the task you want it to perform.
Right. Yep.
Interesting. Okay, so supposing I Actually, no. In fact, supposing I don't know anything about any of these things, how do I actually get started?
Yep,
Because,
that's a great question.
yeah,
Yeah,
okay.
yeah, I think that's a great question. So the first thing, or the first rule is don't jump on the latest trend, right? And speaking from personal experience, I think doing one of my research with my supervisor, we actually got to know that um, using transformers wasn't actually the right architecture to use. But then using convolutional neural networks actually performed much better than using the transform architecture. And I actually also recently saw a paper that actually said the same thing, that using convolutional neural networks for some very specific tasks actually outperform transformers, right? So the first thing is keep an eye out, keep an ear out to what's actually going on, but don't jump on the latest trend, right? And then if you're starting out, the first thing is to actually define what success looks like to you, right? So why exactly do you want to get into like AI, for example, right? Maybe you want to acquire some skills, you want to get like a job or whatever, right? You want to get into research. So define what success means like to you or what you're actually looking out for. And then the second step is actually to build our systems, right? So let's say every week I dedicate, or let's say every Monday at 2 o'clock p.m., I dedicate 2 hours to learn about AI, right? The third one is during your learning process, learn just enough, right, as possible, right, to actually start building our stuff. Because what eventually happens is if you concentrate on learning, you'd be stuck in tutorial hell, right? We looking at tons and tons of tutorials, but actually building. So learn just enough, right? Not everything, just enough to actually get started building, right? And when you start building, based off of that on project-based learning, right? So pick a project, right? It could be like a blog or a YouTube video. Just follow along and then build it out, right? From end to end. Now, once you're done building it out, move back and then build it yourself, right? Once you build it, try adding something to it. Maybe with the projects, they actually use, say, climate data. Try using health data, for example, and think of ways to actually also model, adapt that to like different cases. So basically, like thinking different as to like what you can actually do with it, right? And I think for people also starting out, it's really helpful to actually look out for mentors, right? I think one of the things that actually helped me out when I was starting out, when I think first year, I was like really struggling. And then I reached out to Dr. Emmanuel Ahene, right? And then actually like held my hand, right, throughout the research. So I think he's the one who actually like held my hand through research and then taught me a lot, right? And then the second thing is also like finding people, like-minded people, a community, for example. I think in our class we had like lots of groups of people who actually had like their own communities building stuff, right? So I came across Emmanuel, who was also into the ML AI space, and then we actually like participate in hackathons, for example, together. Yeah, so I think those are like some of the main points to look out for. So communities, mentors, and one other thing I'd also like to add is um, you also have to connect to people, right? So if you see someone whose work interests you, reach out to them, right? I mean, what's the worst that could happen? I think that's something I actually always ask
They will
myself.
ignore you.
The worst that could happen is they actually don't reply. I
Yeah.
mean, I'll move on to the next person. And it will surprise you that most of the opportunities that I got, right, yeah, it mostly because I reached out to people. And I think people, for example, founders and students underestimate just how helpful and important, for example, social networks are. For example, LinkedIn, X, formerly Twitter is, right? So most of the opportunities I got introduced to were either from people I know or from LinkedIn, right? So yeah, and also if you're actually building those projects out, build them in public, right? The surprising thing is people are actually willing to help, right? I think that's a fact that actually like shocked me, right? I was like, all over my hair, I was like, wait, I'm actually gonna text this person, what if they don't reply? What if they see me as like a novice or something, right?
Yeah.
People are actually really willing to help, and it surprised me. It's like really, right? Yeah. So I think that was also like one helpful tip, and also to build in public. I think if you build in public, people actually see what you're building, and if you're actually excited about it, you'd actually reach out to you, right? Yeah. I think yeah, building in public is like really cool. I think I'd actually recommend it for like everyone to do that. do it in public, let people know what you're actually working on. Um, you could actually like get introduced to lots and lots of opportunities. It also helps you like document your learning path, right? It's something you could also like go back to every time you want, and then see like how far you've come, right? I look at some of the projects that I did, where I was like, wait, did I actually do that? Yeah. So yeah, I think these are like really helpful tips for someone who wants to actually get started. Yeah.
All right, all right. That's really you've actually given like a lot more advice than I thought you were going to give, but that's very comprehensive. Okay. And actually that's something I think I've noticed, I guess. When you are talking about something, you really try to exhaust the point. Which yeah, it's a good thing.
Yeah.
Or at least I find it to be a good thing. I don't know, but yeah, I find it to be a good thing.
Yeah.
Okay. Um, what? Give me a second. Let me check the time. I think. Okay. Okay. We have about 13 minutes. All right. Then
Awesome.
we'll move on from AI. Although there are still a few more things I'd like to ask in that aspect. Maybe we'll
Yeah.
have another session one day.
For sure.
Okay. So, what do you usually do during your free time? How do you like to relax?
For one, I actually like going on walks. I think the longest I've been on is almost 4 hours. I like walking a lot because I think it clears my mind and also it helps me think through stuff. Um, for example, I think there is this ongoing joke or insider joke with developers that you could like sit behind your screen for hours and hours debugging something. Then you go out, come back, take a shower, sit behind the laptop for 5 minutes, and then it just comes back at you, right? Yeah. So I like walks. I mean, aside like the exercising part, I think it actually like helps me clear my head. And also, I actually used to play the piano in my free time, but not anymore. I know the basics, but yeah. I try to also sometimes watch Formula One racing. Yeah. But then I think we have like a break until next year. So yeah, I'm waiting around. Yeah, and I also try to like watch some sci-fi, um, maybe some books sometimes. I guess. Yeah, that's basically it. Yeah.
All right, all right, all right. That's really cool. Funny thing is, I actually always wanted to learn how to play the piano myself.
Oh.
Yeah,
Oh, okay.
but do you have a piano? Like, do you have the actual piano at home?
No, mine got
Oh,
spoiled, and yeah, yeah,
okay, okay, okay. All right,
yeah.
that's cool.
I'm sure if you try to find a time, maybe like 20 minutes a day, you could, or like a week, you could actually like still get onto it.
I mean,
It's not
I
great.
actually would have, but there was never a piano around for me to learn.
Ah,
So what I
yeah.
actually ended up doing was I downloaded this piano app on my phone, and I
Right.
used to play like Moonlight Sonata, the Happy Birthday
Yeah.
song, and a few others using just my thumbs. Because
Oh,
I mean, you
yeah.
hold the phone like this, and then you have to, yeah. So
Right, right. Yeah, yeah.
yeah.
That's interesting. Yeah.
Okay, all right. So I think the final thing is, is there anything you'd like to say to anyone who might be watching? Anything at
Uh,
all, whether it is an advice, whether it is anything. Maybe
right,
you want
right.
to advertise something.
Yeah.
Considering the fact they're actually working. Actually, you know what? No, I'll ask after the meeting ends.
Okay, okay.
Yeah, concerning the advertisement thing you were talking about.
Right,
Yeah.
right. Yeah, for sure. I think first of all, um, in this space, like as a developer, as a builder, I think one thing to actually really develop is like resilience. Um, so it's actually lots of like experimentation, lots of like building. You're actually gonna feel like a lot, right? So I think one thing to have is like resilience and like a growth mindset. I was like can actually fail, actually learn from it. So I think I actually took this lesson from I don't know if it's from a book I think it's from the obstacle is the way. But then I think circling back to the first point I made, where you actually define what success looks like. If you actually define what success looks like and have like those systems in place, right? So if you're actually learning something, you define what success looks like, have systems in place, right? You actually tend to enjoy the process more than even the outcome, right? And then if that outcome even turns out to be negative, right, you still won because maybe at the end of the process, you actually learned something, right? Or you actually maybe met someone new, for example, right? So I think one very great mindset to have is to have like a growth mindset where like every failure is like an opportunity to learn and then get better. So yeah, I think this might sound cliche, but yeah, never give up. Yeah, and then keep at it. Yeah, yeah.
Okay, okay, all right. Interesting. Okay, so if my definition of success were to see a certain project I'm working on get commercialized and gain traction, right? And I'm not able to hit that. How do I frame the question? Do you think, oh no, how would I compensate for the fact that I wasn't able to hit that? I mean, yeah, I might have learned a few things along the way. I might have met a few people, but at the end of the day, what I really wanted, I wasn't able to achieve that. Right. So how do I console myself?
Right, right. Right. That's a great question. And I think one thing people actually get about like failure, for example, is that it's actually bad to feel the feelings you're feeling. No, I like yourself to feel the feelings, right? And then once you're done feeling the feelings, that's when like the learning part comes in, right? And then I think when I actually like come across a failure, I think when I sleep over it, like for a couple of days, I actually don't think about it anymore. So yeah, feel the failure. But then I think one very great one thing that my one of my supervisors or like mentors told me, I think this week was that so I told him that I actually couldn't make it to a program, right? And they were like, oh, it will get easier the next time, right? So there's always like the next time, right? You
Yeah,
can always
yeah,
try again,
yeah.
right? So based on what you've learned, right? There's always going to be a last time. It's going to be easier because well, it was your first experience. The next time you're gonna kill it, right? Yeah,
Yeah, yeah, yeah, yeah.
yeah,
True, 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 true.
yeah.
Basically, you've learned all the tricks, all the techniques, you've gained the right ammunition.
Mm-hmm,
So
mm-hmm.
even though you've lost the first battle, you can go
Yep,
and go harder, right?
yep, exactly. It's not the end of the world yet,
Yeah.
so we can go harder.
All right, all right, all right. Okay. Wow. Honestly, I have learned a lot from this session because this whole time I've always just had like a vague idea of what AI is, but this meeting has actually given me more insight into that field, and now I have a whole lot more to explore. So
Yep,
I am definitely going to be doing a little bit more research into the field. Maybe even try building my own, fine tuning my own large
yep.
language model. Because I actually do use them. I'm actually starting to use them a little more often in my work, right? Like in my
Okay.
programming. Yeah. So
Yep.
yeah, maybe I can
Yep.
fine tune one specifically for my needs.
Right, right. So, what has your experience been using like AI or like LLMs, basically like for your development process?
Oh, okay. So okay. um, they are good when they come to maybe I'm thinking of implementing something, but I'm not entirely sure what the best approach might be. So I can maybe like ask one of the large language models to give me potential options, and then I go through them, do some research, and then pick one of them, right? The one that would be suitable. Maybe if I'm debugging code and I might not necessarily know what exactly might be wrong. I might, feed the code, feed the error to a large language model and then ask it for its opinion. And then it
Right.
will give me that. But one thing that I've been trying, so I'm a backend developer, right? I like backend is my thing. I
Yeah,
I
my record.
hate I hate front end.
Yeah.
Okay, I don't really hate it, but like I never bothered to learn front end. So
Yeah.
we are working on a new project right now, and I have to be overseeing the front end developers, right? Because I need to explain a few things to them, and then sometimes I actually have to go in there and debug some of the front end code myself. So during that process, I've actually had to learn a bit of the front end myself. What I realized when I tried out this tool, I guess it's by Vercel. It's called VO. It's VO.dev. Yeah, and surprisingly, it can actually build the entire project for you. Just that it's not really as capable as I would want it to be, right? So it can get the basic things like maybe make a page, make some few pages, but it can't actually fully interact with an API because like I'm the backend developer, I've built the API. So you can't really fully interact with the API, put everything together and actually make a complete working project. You can only
Right.
use it to maybe like get started, make a certain page, take that code and then modify it to work for your use case, right? Yeah.
Yep.
So
Yep.
I think that's the main limitation when it comes to using large language models, right? You can't really get it to do everything for you, but it's a
Yep.
good way to get started, and it's also a good way to come up with some ideas or also debug a few codes, a
Yeah.
few bugs. Yeah.
Yeah, that's a really great point. I think I've also have like my personal experience with like what Zizi mentioned, where it's also like it's really helpful on the ideation phase sometimes.
Yeah.
But then sometimes if you actually don't know what you're doing, you actually spend like hours right debugging the AI
Yeah.
generated code, which you could actually use to build it from scratch,
Yep.
right?
Yep.
So actually,
Yep.
yeah, it's a really great point. Yeah,
That actually happened to me
yeah,
when I was trying to figure out the front end from the beginning. What I actually started doing was I was trying to use AI to just the LLM to just build everything, and it
yeah.
ended up running into one problem, and I tried
Uh,
solving it for so long.
yeah, yeah, yeah.
Oh my goodness.
So yeah, I think that's like one weakness with them. But someone actually did introduce me to. Actually recently heard about it. It's called like co-founder. Maybe I'll send a link to you later on, or
Sure.
maybe someone actually wants to learn more about it. I think it's generates like full stack code or like full stack web pages from database. Yeah. So I haven't actually like dug into it, so I don't like know the intricacies of it. But I think it's like something really cool to explore, and maybe also to explore like how far I can go, and then
Yeah. Yeah.
like the
Exactly.
levels, for
Yeah.
example. And I think one other thing I also came across was Genesis. I think it was released yesterday. Basically, generates 3D worlds for robots. Generates um, like 3D renders, like 4D physics, like renders for stuff. So
Yeah.
you could have like a drop of water, and then you could actually visualize aside like generating it. You could actually visualize the forces being exerted on it. For example, generates like a robot interacting with, say, picking up a box. You can see like
Yeah.
the force everything.
Yeah.
I think it was pretty cool. So I think, yeah, it's exciting, right? How yeah, based on like
Very
AI,
excited. Yeah.
yeah. Yeah. So yeah, it's an exciting time to be alive and to build stuffs. Yeah, yeah,
Definitely. 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 Wow.
yeah.
Interesting. Well, I guess we just I don't know if I should say wait and see because I mean we are definitely part of the revolution, right?
Right.
So oh yeah, I guess time will reveal all the new things, all the
Yep.
upcoming things.
Yep.
Coming to think of it, there was this question I asked. I'm not sure if you watched that episode or that entry. Tracy, she's a
Mhm.
data scientist, and
Yeah.
the question I asked her was: supposing we had all the potential variables, would it be possible to predict with utmost certainty an event in the future, right? And considering the fact that large language models, AI in general, is also sort of it's very predictive in nature, right? It takes the data, analyzes the data, and then uses that data to actually predict what the right course of action would be, right? Do you think with AI that would be possible?
Uh,
Supposing, okay, so let's okay, yeah. Let me not Let me not add more parameters. Let's just end it there. Do you think that would be possible?
that's a tough one. I think I actually saw a movie called Minority Reports, where they could actually be able to predict when a crime could happen.
Yeah. I saw that movie.
Yeah. So it's possible. I mean, in a perfect world, right, where you could actually account for like all variables,
Yeah,
it's actually possible. But then human beings are actually unpredictable, right? So I think we are like the outlier when it comes to like the variables. But then I think it's possible. So I think recently I came across the news where I think one problem with weather or like climate is that it was like really difficult to actually give accurate weather and climate predictions. But then recently, Google DeepMind has been able to come up with an algorithm that is able to do that, right? So I think it's actually really possible. Yeah, yeah,
so we just need to get all the variables from
right,
every single atom to every single
right,
star to every single galaxy.
right, right. And then there are also those who say we live in a matrix. So
Yeah, simulation, and yeah, there
yeah,
are so
yeah.
many theories out there. What's the most interesting theory you've ever heard
Um,
about everything, like about life and reality?
the most interesting theory. Hmm. Well, maybe this isn't like a theory per se, but I think one of the interesting things I actually come across is that actually the people we meet actually aren't by chance. I guess. Yeah, I think that's really interesting, and also I think personally I feel like moving forward, everything that actually happens looking back actually makes sense. It basically seems like connecting the dots,
Yeah,
right? Yeah, as you move forward, you actually look back, you're like, oh, okay, this actually makes sense.
yeah,
I mean,
this
at that
happened
time,
because this
yeah,
happened. Yeah,
yeah,
exactly.
exactly, right? So, yeah, I think that's something I actually find really interesting because sometimes they are of like, oh, okay, so if this hadn't happened, I wouldn't actually have seen this, for example, right? Or I haven't actually would have got opportunity to experience this, for example. So, if I met this person, for example, right? If I met you, for example, right? I mean,
Yeah, I
so
mean,
I think
this wouldn't be happening today. Yeah,
right. I think it's an interesting concept.
yeah, yeah, yeah,
Yeah.
yeah.
I mean, what's yours? Do you have like an interesting
What's
theory?
mine?
Yeah.
In terms of theories, I would say the most interesting one for me is the concept of living in a simulation, right? Because I mean, if you think about it, it's like everything we are experiencing here, everything that's happening here is not really real per se, and it's just like there's sort of like an entity or entities or whatever that have created their own simulation and just letting things play out, right?
Yep. Yep.
And potentially we could actually also do something like that, right? Where we create our own simulation, and then the people within that simulation will be living their life,
Right.
and it could keep
Right.
going on and on and on and on.
Exactly. Yeah, I think it's really interesting. I don't know if you've heard of this Stanford research that they did. I think they actually had like these AI agents, right, inside I think a space, right,
Oh,
and
and they
then
were trying to figure out if they knew that they were. Yeah, yeah.
exactly
How did
right.
that conclude?
I have no idea, but I think they actually were able to collaborate and do some stuff. But I have no idea. Yeah, I think so. I think it's actually really an interesting theory where you actually we could actually think about some sort of like entities who have actually created like this simulation,
Yeah,
and then we could also like have like for now AI agents who actually simulated, right? And then actually could actually think of themselves as like real. They could also like go ahead and then simulate some other styles.
yeah, yeah, yeah.
Yeah, I think it's a whole rabbit hole, but then it's interesting. Yeah.
Oh, okay, interesting. There's actually one more question I personally want to ask. I I want to build a game, right? And hypothetically, I mean, I actually do want to build a game, but hypothetically, considering the fact that we have large language models now and they can, generate text and things like that, potentially we could actually build a game where every single action that happens in the game is unique for every single player. And it's not like the current games that they give you choices and you select choices and you get to a predetermined ending for each choice. Everything is just unique. So based on what you do and based on what the characters in the game also do, you end up getting a completely different outcome. How possible do you think that is?
Yep, that's actually possible. That's actually possible. I think I came across this Hugging Face developer who actually was using reinforcement learning in games. So I think there's actually a course, right? I could also like send that over.
Yeah.
So yeah, so
Definitely.
yep. So basically, like you did mention, I think for games we have now, they are mostly like predefined for some very specific characters. And I think that's actually evident in, for example, GTA. I think for GTA, you are always sure that this character is going to behave this way.
Yeah.
If they get stuck, that's it,
Yeah.
right? So I think in that game, we're actually able to use like large language models and then reinforcement learning to actually have like unique or like dynamic like behavior for every NPC, if you will.
Yeah.
Like, I think that's like really interesting. For example, in robotics, I mean, in games specifically, for example, right? Yeah, I think it's totally feasible and totally possible. So yeah, I think you should definitely check out Hugging Face. They have like even a course on that, how to actually build out like AI characters,
Yeah.
for example. Yeah, yeah.
Interesting.
Yeah.
Okay, I have a lot of research to do.
Yeah, same here. Yeah,
All
awesome.
right, so yeah, thank you very much for making time to educate me and everyone else who's going to watch.
Yep. Thanks for having me. Thanks so much for having me. Yeah, it was really interesting being here.
Yeah, definitely. It was a pleasure.
Yeah.
All right, so till next time, I guess.
For sure. Awesome.
Bye.
Bye. Okay.
As you say, you are done. So you are done.
Sure. Bye.
Thank you for organizing these shows.
But yeah, it's been a fun time. So we'll catch you all next time. Bye bye.